In the last lesson, we covered basics of APIs and even integrated with emailable service to do email validations. We put most of the logic and the code within this controller here, and the controller should not be responsible for too many things. It should not be making any API or cURL requests directly. So in this lesson, we're going to refactor this and make it better. We will also install and use Guzzle HTTP client instead of using cURL. And at the end, we'll integrate with another email validation service API so that we can easily swap out the implementations when needed. Alright, so the first thing that we need to do is that we'll copy this code and then remove it from this controller entirely. And instead of making any cURL requests directly, we'll inject some kind of email validation service in the constructor. We'll call it something like email validation service. And then within the controller method, we'll call some sort of verify method on that email validation service. We can pass the email as an argument, and maybe this will return an array of result, and we'll assign this to a result variable, and we'll simply dump the result on the screen so we can test it out. We'll hard code the email for this example. Now let's create this email validation service, and we'll create this within app services emailable namespace because we're implementing emailable API. So we'll put it within its own directory and namespace. Let's create a new function here called verify, which accepts email as an argument and returns an array. We can then paste in the code that we've copied here, and we can adjust it from here to make it better. We can get rid of this email from here because we're accepting that as an argument. We'll also get rid of the echo statements from here and simply return JSON decoded value. The next thing that we can do to make this better is that we can remove the API key dependency from within the verify method. What I mean by that is that currently we are kind of tied to this single API key. What if somewhere in our application we wanted to use a different account for the emailable service? Maybe we had 2 or 3 accounts and we want to use one account, and from a different part of the application we want to use another account, and so on. Right now this is tied to this single API key, and the only way to switch the account is to update this environment variable. It would be much better if we accepted the API key within a constructor in here. And then we can get rid of this and we'll replace this with API key. The next thing we can do to improve this is that we can extract the base URL into a property, because maybe we are going to have more than one method that will use the same base URL. Because as you remember, the emailable API has 2 endpoints. One is to verify a single email and the other one is to verify multiple emails. APIs can have more endpoints, so instead of duplicating this all over, we can put this into its own property. So let's test this out. We'll open the browser, visit localhost port 8000/curl, and we're getting an exception. If we go back to the curl controller, we're injecting email validation service as a dependency here. So the container is trying to instantiate this class for us, and then this class itself has a dependency of its own. And this dependency is not a class, it's a scalar value, and therefore it does not know how to instantiate it. That's why we're getting this exception. We can fix this by telling the container how to instantiate the class and pass the necessary API key in its constructor using container binding. So if we open the app.php where we are binding our classes to the container, we can do something similar to what we did with the mailer interface. Now we don't have an interface for this example yet. We'll get to that later in this lesson, but for now we'll simply bind email validation service to email validation service, but we'll pass the necessary API key. So we need to create a new option in our config. So now we'll add this to the config class and we'll get it from the environment variable. All right, let's close this out and let's test it out to make sure that now it works. We refresh the page and sure enough, now it works and we're getting the result back. Now let's replace the curl with Guzzle HTTP client. As you know, the Guzzle is PHP HTTP client that we can use to send HTTP requests. So let's pull it in using Composer. While this is installing, let's open the documentation so that we can see an example of how we can make an API request. So first thing that we need to do is that we need to instantiate a new client object. This is where we can pass the base URI as an option within the constructor along with some other options that might be needed for the client. Then we can make a request by using the request method, or we could also make requests by calling a specific request type method like get or post and so on. So let's go back to the code here, and instead of curl init, we'll create a new client. We'll pass the base URL option as well as the timeout option, and the timeout is the number of seconds it takes before the API request times out. We'll set the timeout to 5. Next, we can make a GET request using the GET method. So if we take the client and try to get all of its methods, we see that we have a bunch of methods auto-completed here. So we can do GET, we can do POST, we can do PUT, and so on. Or we can simply do request and pass the method as an argument. In this case, we need a GET request, so we'll do GET. We'll pass the rest of the endpoint as the first argument. In this case, that's this part right here. So we'll take that, we'll put it here, and we'll simply move the params above here. And as the second argument, we can pass options specific to this request if needed, like headers and so on. For this example, we don't really need to pass any specific options except maybe just the query params. For example, right now we are passing query string this way, which will work, or instead of building the query string ourselves, what we can do is that we can pass it as an array. The option for that is called query, and we can pass params directly like this. So we can get rid of this from here and we can remove that. You can check the documentation for more information on what options you can set for both the default options for the client or the options specific for the request. I'm going to leave the link to the documentation part in the description, so check it out if you want to know what options are available. Alright, so if we inspect the GET method here, we see that it returns an object of response interface, and the response interface is one of the interfaces offered by the PSR. So we can assign this to a response variable here, and we could get rid of all of this from here, and now we need to get the body or the content of the response that we can return. We can call the getBody method on the response, but the getBody method returns an object of stream interface. So we need to call the getContents on that to get the actual content. Now we can apply the JSON decode to this, and that should work. Let's test this out. Let's refresh the page, and sure enough, everything is still working. Now let's see what happens when something goes wrong, like we get a 404 or some kind of server error. We can simulate that by having a typo in the endpoint. That way it triggers a 404 response, and then we can see how that's handled by default. So we can add some typo here. Let's refresh the page. And after a few seconds, we get a client exception with the 404 not found response. Now, as you can imagine, APIs, while most of them are reliable and have 99.99% uptime, there are times when it's unreachable. Maybe there is some maintenance going on, or we've made too many requests in a short period of time, or there was just some random glitch. We don't want our application to fail on the first try as soon as it encounters some kind of client error. We want to give it a couple of chances before we let our application throw an exception. This means that we need to build some sort of retry functionality so that requests are retried a few times on certain status codes or on certain exceptions before finally throwing an exception. Now, each API would have documentation on the status codes it can respond with and its descriptions. For example, if we open the emailable documentation, we see sections for rate limiting and status codes. Let's click on status codes, and as you can see, we have list of statuses that it can respond with right here. So after reading these, 249 status code as well as 429 and 503 are the ones that we can build the retry functionality on. Because 503 is a maintenance mode when the API is temporarily down, so we could retry a few times to see if it has resolved. 429 is too many requests, where we've made too many requests per second or something like that, so we can have our script sleep for a couple of seconds before retrying again. And 249, the response stays to try again. Your request is taking longer than normal, please send your request again. On the other status codes, it doesn't really make sense to retry. For example, on 401, that indicates unauthorized access. So what's the point of retrying it multiple times? A second or third retry is not going to make us authorized. It just means that we did not send in an API key, or if we sent in a wrong API key, we would get 403 forbidden, and we would just be wasting resources if we kept on retrying on such errors. This will of course vary from API to APIs, and also will depend on how you want to structure your app. You may not want to do retries at all, or maybe only retry on a single status and so on. In our case, we're going to build retry functionality for 249, 429, and 503. There are a couple of ways we can build the retry functionality. One is to build it completely from scratch by wrapping this in a try-catch block and catching Guzzle specific exceptions, which would allow us to check the status codes, and then we could have some sort of recursive call to the API method to make the request call again based on some decider logic, whether we should retry or not, and how long we should have the script sleep, and so on. Another way is to use something called Guzzle's handlers and middleware feature. I actually found out about this recently while working on notes for this lesson, which I didn't know myself, that Guzzle has a built-in way to handle retries. So let's open the Guzzle documentation and we'll click handlers and middleware section right here. Middleware is basically some part of code that can be executed or ran in the process or in the middle of something else. You can read about this yourself on what they are and how they work, or how to create custom handlers and so on. But basically, we can create a handler stack and then push the necessary middlewares to it and set the custom handler if needed. Then we can pass this stack as a handler to the client constructor as an option. So let's go back to the code and let's create a new stack. So we'll do stack equals new handler stack, and we'll try to push a new middleware. As it turns out, as you saw in the documentation, there is a middleware class that offers some built-in middlewares. So if we try to inspect some of the methods that are available on the middleware, we see that there is a retry method, which is not in the documentations. The middlewares are basically just callable functions. As you can see, the retry static method here just returns a callable function. The retry middleware callable function, as you can see, accepts two callable functions as arguments. One is the decider and the other one is delay. Decider is basically a function that will decide whether we should retry the request or not. It should return either true or false. If it returns true, then it's going to retry. If it returns false, it's not going to retry. And then delay is basically a function that should return number of milliseconds to delay retrying the API request. The delay function, as you can see, is optional, and if null is passed, it is going to use a default delay, which is exponential backoff delay, which basically makes script sleep longer than the previous time based on number of times it has already retried. I know this all sounds kind of complicated, but if we actually inspect the source code, we'll see that it's actually pretty simple. Let's inspect this retry middleware class here to see what it does. We see right here right away that if delay is not set, it is calling exponential delay method on the current class. And if we scroll down, we see that method right here. And we see that this method is nothing more than a simple power function based on number of retries, which is multiplied by 1000 to convert to milliseconds. Now let's search the decider to see where it's actually used. So we'll search for the decider, and we see that it is used on onFulfilled method. We see right here that the decider function is actually being called, and it passes these arguments right here. So these arguments are actually available in our callable function for the decider. The first argument is number of retries, meaning number of times it has already retried. The second one is the request interface object, which is again provided by the PSR. The third one is the current response, or the value for that response. And the fourth one is an exception, if any. In this case, it's null. If the result of this callback function call returns false, then it is not going to be retried, and we simply return the response, or whatever the value is. Otherwise, if the return of this is true, then we do the retry. So as you can see, it's actually pretty straightforward on how this works. Now if we scroll down a little bit more, we see that decider is also used on rejected. So if something goes wrong, it again calls the decider function, passing the retries request, passes the null for response, and passes an exception or the reason as the last argument. And again does the same thing. If this returns true, then it's going to retry, otherwise it will just do this. So now we know more about how to build our decider function, because we know what arguments are being passed to it and what arguments are available. So if we go back here, we're not going to pass a custom delay function. We'll just use the default exponential backoff. But for decider, we'll pass a callable function. Now, as we saw, this function accepts number of retries, request interface, optional response interface, which can be null, and optional runtime exception. Let's format this code, and we can now build our retry logic. First, we need to make sure that the number of retries is less than some sort of max retry. So if retries is less than some max retry, we can continue to check the logic if we need to retry or not. Otherwise, we need to return false. So instead of doing this and having an if-else block here, we'll simply do if retries is greater than or equal to max retry, we'll simply return false. Now what we need to do is that we'll take max retry and create and hardcode this value to something like 3 in this case, but this doesn't need to be hardcoded. It can be passed as an argument if needed. So we'll simply use that here, and first part is good enough. Then we need to check if the response is available. If we have response, then we can check the status code and check if the status code is either 249, 429, or 503. If the response code is one of those, then we can do the retry. Otherwise, we can do other checks. Now, of course, we don't have to hardcode this here either. This can be extracted into an enum class if needed, but for the sake of simplicity, we'll just keep it this way. Finally, if we have no response, then we might have an exception. There could be different types of exceptions that can be thrown. If we go back to the Guzzle HTTP documentation, within the quick start, we can click on exceptions section here, and we see the hierarchy of the exceptions. So we have the connect exception, request exception, and so on. And these extend from transfer exception, which in turn extends from runtime exception, which is why I type hinted as runtime exception there. Now, if the exception is a connect exception, we can retry the API request, and the retry might resolve it. So we'll do if exception is instance of connect exception, return true. Otherwise, return false. Now again, this will depend on your specific implementation on how you want to handle the retry logic, which is why the Guzzle does not implement this for you. Instead, it gives us the flexibility to provide the full implementation on when to do the retry and for how long to wait for each attempt. We could also check for request exception and try to get response from that to check the status code, but we're going to keep it simple for this example. Alright, so I think we're good here. The one thing that I want to do is that I want to actually extract this to its own method to return the retry middleware. So it would look much cleaner if we called some kind of get retry middleware method, and in here we could pass the max retry as an argument. Now let's create this method here, and we'll simply return this. Now we need to pass this stack as a handler option to the client. So we'll do handler equals stack. Now before we test this out, let's add some echo statements here so that we know when we're retrying and for how many times it has retried. Alright, so let's test this out. Now note that we're triggering a 404 error because we're using the wrong endpoint on purpose. That is not going to do any retries because 404 is not part of our retry logic. So let's refresh the page to confirm that. And we're getting an exception here that no handler has been specified. I think because we have an issue here within the handler stack creation. Instead of doing this, we can do handler stack create, which should work. The difference is that if we inspect the create method, we see that if no handler is given, it is using some sort of default handler. However, if we instantiate the class ourselves, it does not set the default handler, it is set to null. And that's probably why we were getting that error. So using the create method should fix this issue. So let's go back, refresh the page, And as you can see, it is not retrying on the 404 status. It is retrying on the connection error because the first time we got some sort of connection error with the API request. However, after that, it is not retrying because we're getting 404. Now, if we go back here and add the 404 to be part of our retry logic and refresh the page, it is going to now retry a couple of times. And as you can see, it has retried 2 more times because of the 404 error. Alright, so I think we're good here and we can remove the echo statements and fix our typo in the verify endpoint. Before I do that though, one thing I do want to point out is that, as you probably noticed, the API key here is visible in the exception. And you need to be careful on how you handle such exceptions. You don't want to display sensitive information on the screen like this or even log it anywhere in the system. So the one thing you can do is that you can wrap this in a try-catch block and throw a custom exception within the catch block without the sensitive information. Alright, so we're just going to leave this the way it is for now, and I'm going to remove the echo statements since we no longer need that. And we're going to fix our typo and refresh the page to make sure that it still works. And sure enough, it works. Now let's see how we can integrate a second API that does the same thing. Maybe we want to have a fallback logic so that if we run out of credits from this service, we fall back to another service that does the same. Or maybe down the line we want to swap out the implementation and switch to a different provider. Right now the issue is that we're being very specific about the implementation in our constructor dependency injection right here. We are injecting a specific emailable email validation service in our curl controller. Now we already covered how we can tackle this problem earlier in this series, and that is to use interfaces. Instead of expecting a specific emailable email validation service, we can expect some sort of email validation interface, which the email validation service will implement. So we'll create this interface within the contracts namespace, and this needs to have a single method called verify. So we're just going to copy the definition of this and paste it here, and we'll implement this within the email validation service. Now the only thing left to do is that within our app.php, when we're binding the specific implementation, instead of using a concrete class, we can simply use email validation interface, and this should still work. Now if you go back to the browser, refresh the page, we see that it still works. So now that we have this interface, let's quickly integrate with another email validation service. I'm going to use Abstract API for that, which has various APIs including the email validation API. Just a quick note here that this video or the previous one are not sponsored by any of these companies. I was not sponsored by Abstract API or Emailable. These are just the APIs that I decided to pick for these examples. So if we scroll to the documentation, we see that we have this endpoint and we need to have an API key. So the overall structure looks to be similar. So let's create a new directory within our code. So within the services, we have Emailable. So we'll just simply create another directory called Abstract API, and we'll simply copy the email validation service there, change the namespace to Abstract API, and now we just need to adjust this code to make it work with Abstract API. The first thing is that we need to change the base URL. So if we go back to the documentation, the base URL is this. So we'll copy this and replace this. Then within our verify method, we need to get rid of this endpoint because we no longer have any specific endpoint. This is the whole endpoint, basically the base URL. The request params, however, are the same. So this will stay the way it is. They might have been different if we were using a different API, and authentication might have been different, but in this case we got lucky and they're similar. So just because these two APIs are similar, it does not mean that other APIs would be. Also note that the retry logic is pretty much the same. Now there might be differences on which status to retry from API to API, but for the most part it is going to be the same. We could extract this into its own class and make it more flexible and inject it in both constructors for Emailable email validation service and Abstract API email validation service. I'm going to leave that for you to do as an exercise if you're up for it. Now let's open the dashboard of Abstract API so that we can grab the API key. I've already made an account with them and have logged in behind the scenes. So I'm just going to copy this API key and add it within our environment variables. So we'll open the env file, and in here we can put Abstract API email validation API key, and we need to add this to our config as well. So let's open the config class and we'll change this to Abstract API email validation. For this example, as I mentioned, we're going to test it out by simply swapping the implementation using the container. In other examples, you might want to have a factory class which would be responsible for giving you the right implementation based on some arguments. So we'll replace this with the email validation service from the Abstract API. In fact, we'll simply get rid of that from here so that we can import this one. And let's format the code, and this should be good enough. And I almost forgot, we need to change this from emailable to Abstract API email validation. Now let's refresh the page and notice this is the emailable data. And as you can see, we got a different set of data because now we are using Abstract API instead of emailable. Now, as far as the structure goes, we're going to talk about something called DTOs or data transfer objects in the next lesson, so stay tuned for that. So this is it for this video. Thank you so much for watching. Smash the like button if you liked it and subscribe to the channel if you haven't already done so. I'll see you in the next video.